Welcome to our KMC training camp, and today we are going to discuss the 9th practice. It's about spatial imagination. I really hope all the 3 questions can help exercise your spatial imagination. Let's see how can we solve them. For the first question, what does Pepe the clown see when he looks at himself in the mirror? Okay, so in fact, we have discussed the mirror image in the first day. So let's see, what kind of features or properties does mirror image have? The first part, so the reflection or the mirror image must be as close as ourselves when we look into the mirror. That means if we draw a mirror here, let's draw a mirror here. So every part of the clown in the mirror or its mirror image must be as close to the part of this clown itself. Okay, and also the second feature for mirror image is about the right and the side direction. So that means the left side of this clown must be on the right side in the mirror image. So just like this, you can see the flower. At first, it points to right, so the mirror image must be points to the left, like this. They are as close to each other. Okay, this is a flower. Now we can exclude C and E because the 2 options, their flowers points to right instead of left. And let's check the hair, because on the right it should be a smaller hair, while on the left it should be larger hair. So in the mirror, the smaller hair must be on the left and the larger one must be on the right. So they point to different directions or they point to opposite directions as the clown itself. And in this way we can exclude B. Okay, so exclusion is a very useful method when we are solving multiple choice, right? Let's see. The 2 sleeves. They have different number of circles. At first, the left one has 4 circles, while the right one has 3 circles. So that means in the mirror, the left one should have 3 circles, while the right one has 4 circles. Sorry, I didn't draw that in a perfect way. So this is the hand, and the left sleeve have 3 circles, while the right one should have 4 circles. Okay, now let's check which one is correct. It's very clear now. Yeah, it must be A. So the answer for the question 1 is A, and question D, you can see option D. It has 4 circles on the left and 3 circles on the right, so it cannot be the correct answer, right? 2 major properties for mirror image for mirror symmetry. The first one is about distance, and the second one is about right and left rules. Okay, so hope you can master and remember these 2 points. Let's take the second question. In the picture, we see an island with a highly indented coastline. Oh my god, so many curves and several frogs. How many of these frogs are sitting on the island? Now let's check. So this question, in fact, is to test our good habit of marking. Because now, first, we have to know one thing. This coconut tree must be sitting on the island instead of the ocean, right? So we can start from this point to see, to check, to highlight all the parts and all the area of this island, just like this. Yeah, so it can remind us which part is the island. Let's see, this part must be island. And after we mark the island area, it's easier to check how many or which frogs are on this island. Yeah, just like this. Okay, just follow each branch to the end until you are to the dead ends. So how about this part? Yes, another branch. We can't miss it. And also this part. Because if you paint it with full colors, it's very hard and it will take you many time. So, in fact, you just need to use this. Yes, we just need to paint it into shaded area. Now we can start to count. Yeah, how many frogs are on this island? One, two. Oh, sorry, not this one. 1, 2, 3, and 4, 5, 6. Okay, so after we paint the island into shaded area, it's easier to find and distinguish which frog is on the island. Okay, so we can see the correct answer for second question as B. Now let's see the last one. Jack built a cube using 27 small cubes, which are colored either green or white. We can see them in the figure. Now 2 of the small cubes, which are the same color, have a common face. Okay, this sentence is very important to solve this question. We have to understand it. What does it mean? Now 2 of the small cubes, which are the same color, have a common face. In other words, no 2 adjacent cubes are the same color, or all the adjacent faces or adjacent cubes must be different colors, just like this. So that means the gray one must be next to the white one. And also this one should also be white because it's next to gray. So first we have to understand the important sentence and the important requirements before we start to solve this question. Okay, so the question is, how many white cubes did Jack use? You can see we can't see every cube in the picture, but we can see all the cubes in the first layer. So why not count white cubes layer by layer? Let's see the first layer first. It has 1, 2, 3, 4 white cubes. It's very easy to find it, right? And let's see, because there are 9 cubes altogether in the first layer. So that means there are 5 gray cubes in the first layer. Now let's think, because no adjacent cubes can be the same color, or so. You can see, if we want to find white cubes in the second layer, this is the second layer. Where are they? They must be under gray cubes in the first layer, right? Okay, so that means how many gray cubes in the first layer? How many white cubes in the second layer? So in the second layer, we got 5 white cubes. And for the same reason, there must be the number of white cubes in the third layer or in the last layer must be the same as the number of gray cubes in the second layer. We just need to check. There are 4 gray cubes in the second layer. So that means there are 4 white cubes in the third layer. We just need to add the 3 numbers together. We can get, okay, so that is 13. Okay, there must be 13 white cubes altogether in the figure. So you see, if we just count them layer by layer and reason about the white cubes in the second and the third layers, we can solve it in a very clear way. Okay, so that's all for today's practice. You can see when we are using our spatial imagination, sometimes we also need to use our logical reasoning to solve math problems. Hope you can master all the 3 questions in a perfect way. See you tomorrow. Bye!